Looking at the neuromuscular junction, we're going to start with the end of a neuron. Now, we're looking at the axon terminal or axon bulb of a motor neuron here. It's going to come into close proximity, but not touch, the outside edge of a muscle cell, so the sarcolemma. So what we're seeing here, if we start at the very top, we're looking at those green arrows coming down. Now those green arrows are going to be the action potential, the electrical signal that's coming down because of the movement of ions, the change basically in polarity. As that action potential comes into the axon terminal, that's going to trigger some voltage regulated channels to open. What happens here is these are going to be voltage regulated calcium channels. Calcium is going to flood into the cell. This increase in calcium is going to cause these synaptic vesicles to come down and release their contents. Now inside these synaptic vesicles are going to be acetylcholine. All these little red dots you see are acetylcholine. What's basically happened here is we've gone from an electrical signal, the action potential, was then converted into a chemical signal, the acetylcholine. Now all that acetylcholine is going into the space called the synaptic cleft. This space right here is referred to as the synaptic cleft. Now inside that synaptic cleft, we have all this acetylcholine diffusing from the synaptic vesicles out through exocytosis into the synaptic cleft and heading towards a lower concentration. Well, as it heads towards a lower concentration, it's going to end up binding to the acetylcholine receptors. Now, these right here are symbolizing the acetylcholine receptors. You can notice that the red dots are showing the acetylcholine that is bound there. What's going to happen is we're going to have these binding to the receptors, the acetylcholine's binding to the receptors. It's going to cause these chemically gated channels to open up. It's going to allow sodium, which is found outside here, to come in. So this is going to allow for sodium to enter into the muscle cell. But at the same exact time, it's going to allow potassium, which is found inside the membrane, to exit out. So we'll have both sodium and potassium traveling through these chemically gated channels. But the sodium and potassium do not flow at equal rates. The sodium is flowing a little bit faster than the potassium is flowing. That means we're going to change the membrane potential. The inside of the membrane potential, which was sitting roughly around a negative 70 millivolts, is now going to start to change. Because as you have more positive ions entering into the cell, and not as many positive ions of potassium leaving, that means that the inside membrane potential of negative 70 millivolts is going to become less negative. It's going to head towards negative 69 millivolts, negative 68 millivolts, and it can keep changing at that point. What this is doing, this change in membrane potential, is the start of depolarization. Now, depolarization, think about the term depolarize. You're changing the polarity. So we're going to take this negative 70 and keep going towards 0 or less negative. The goal of the muscle tissue is to reach threshold, negative 55 millivolts. Now, if it can reach negative 55 millivolts, that will trigger what's referred to as your threshold and trigger an action potential. So this neuromuscular junction, the whole process, is trying to take the electrical impulse coming from the neuron, convert it to a chemical impulse, the acetylcholine, and then eventually turn it back to an electrical impulse again of another action potential. And the way that's turning it back into another electrical impulse or action potential is by creating several small graded potentials. Each individual receptor, each individual chemical receptor here, the acetylcholine receptor, can cause a small localized change, a small localized depolarization. If those small depolarizations, those small graded potentials, can add up to reach the threshold, negative 55 millivolts, then you can trigger the next action potential. But if they cannot add up to that threshold, they can't change that negative 70 millivolts to reach negative 55 millivolts, you'll have no action potential. So these chemically gated channels, these acetylcholine channels, by allowing sodium and potassium to pass through, they're creating a graded potential, which is meaning it's causing depolarization at the local environment.